What's going on, guys? My name is Matt and I am back with a new PC build. This time the main focus isn't on the parts in the system, which I will go over those later, but rather the case that's holding all these parts. I've been slowly building this case over the course of the last few weeks and I'm super excited to share the process with you. This isn't 100% done and I need some of your feedback before I do all the finishing touches, but it's at a state where I'm able to build a system in it and show it off. This was one of the more difficult projects I've ever taken on, but I'm very happy with how it turned out and excited to continue working on it. I've been wanting to make a PC case out of wood for many years now. I've even done a few makeshift cases out of wood for super cheap budget builds to save a few bucks, but those weren't really cases and were more just pieces of wood I mounted parts to. With this being said, many of you expressed interest in the last one of those builds with a makeshift case to try and build a more traditional wooden case with a bigger budget and more attention to detail. So with the goal of building a wooden computer case set, I had to start with one of the hardest parts of the process, which was actually designing the case. I started with the idea of getting some nice hardwood planks and building a pretty standard box that would house the components. Then I started to think about airflow. Solid wood is obviously not a great choice for airflow, so I needed a way for the parts to get some fresh air. That's when I got the idea to take thin strips of wood and stack them with each layer pointing away from the next. This would create a box with tons of small slits in it to let air pass through. After getting some of my thoughts on a paper, I headed into SketchUp and began playing around until I got this. This is the first concept for the case, which is basically the aforementioned layering method, but that body being suspended by two solid rectangles. I was kind of playing off the design of those old cheese grater Mac Pros, which is honestly one of my favorite case designs of all time. As you can probably tell from the final product, I diverted from this design, but it wasn't until midway through the build that I decided to do this. So like I said before, this project required strips of wood, and I mean a lot of strips of wood. While deciding on what type of wood I would go for, I started to realize doing this with hardwood could get very expensive very quickly, but then I thought about doing it with plywood. Normally people who build with plywood try and hide the edges that show the individual plies, but I thought I could incorporate the edges as a design element going along with all of the vertical strips. Doing this not only resulted in a visually interesting end product, but it also cost a heck of a lot less. This entire case was constructed out of two 2x4 foot sheets of 1/4 inch plywood. I got these from my local big box hardware store and they were around $9 or $10 a piece. Other than this, the only other material used in the structure of this build were wood glue and a scrap 2x4 that was a few feet long. Before making any cuts, I had to decide the dimension of these strips of wood. I knew the main chamber of the case was going to be the same height and width, so I could just make a ton of strips of the same dimension and wouldn't have to worry about the added complexity of multiple strip sizes. I started by referencing a case that I like, which is the Thermaltake H18. Going micro ATX allowed me to maintain a square internal frame with a space-efficient layout and without needing to increase the box size drastically to fit a full ATX board. After some deliberation, I decided on making strips that were 3/4 inch tall and 15 3/4 inches long. The 3/4 inch height allowed for a very sturdy frame without being unnecessarily large. I knew I wanted the length to be between 15 and 17 inches. Doing some math, you could technically make 3 16-inch sections out of a 4-foot piece of wood, but cutting the wood removes material, so going for 15 3/4 inches more than accounted for the lost material from the cuts. I started by taking each piece of plywood and cutting them into 15 3/4 inch sections. I did this on the table saw, which this project was a big reason why I bought it. These first cuts didn't turn out great for reasons I won't get into right now, but this was also my first time using a table saw, so there was a bit of a learning curve. I next took these sections, turned them 90 degrees, and began to cut 3/4 inch strips. I wanted to cut more than I needed, which I'm happy I did because many of them were unusable for one reason or another. For this project, I had to cut a ton of strips, and while I'm cutting down all these strips, I want to take a minute to talk about today's sponsor, Surfshark VPN. Now, I think a lot of you have heard about all the awesome benefits of a VPN. These include the ability to encrypt your personal information and send it via secure VPN tunnel so that no one unwanted can see it. This is especially helpful on public Wi-Fi. With this being said, one of the best things about Surfshark VPN is all the extra content I've been able to watch because of it. See, depending on where you are in the world, services like HBO and Netflix are going to have different selections of content. By using a VPN, you can access all of this extra content with the click of a button. Some examples of shows I've been watching on Netflix that I wouldn't have been able to without a VPN include Doctor Who, Star Trek Discovery, Brooklyn Nine-Nine, and even more. Beyond just being a VPN, Surfshark offers a number of other benefits. These include Smart DNS, which allows you to use Surfshark with devices like your Xbox or PlayStation, and my favorite feature, which is the HackLock ID protection. This alerts you when one of your email addresses or passwords get leaked. This is really just scratching the surface of the benefits Surfshark VPN is offering. To find out more, you can click the link in the description, and using the code TechByMatt will get you 85% off plus 3 months free, making this as little as a few bucks a month. This is a great way to protect your internet activity, unlock extra content, and support the channel. Thanks again to Surfshark VPN for sponsoring this video, and let's get back to the build. After cutting down around 100 strips, I began gluing them together. I started by just making right angles, 2 pieces at a time. I would apply glue, clamp 2 pieces together, make sure they were square, and repeat. Doing this a number of times left me with 12 right angles, which I let dry for an hour, then unclamped. I stacked these pieces up to see how this design would look in person, and I was super happy with how it looked. I then took 2 of these right angle pieces at a time, applied some glue, clamped them down, checked for square, then repeated. One of the right angles was messed up, so I ended up with 4 double right angles, then the last one I made was a triple. And after these dried, I would glue a piece of wood between one of the 2 ends, then apply another strip in the same orientation, which created a bunch of these U-shaped sections. I then started to glue these sections together and was eventually left with this, a solid U-shaped frame that I could build off of. I put a piece of wood under the frame and set some parts in to begin seeing how everything would look and be laid out. With these parts in place, I began thinking of how I was going to do the back panel. I wanted to maintain a similar look to the rest of the case, but needed cutouts for the various I/O. To do this, I measured how far down a piece would extend, cut some strips down to size, then would test fit them before gluing anything. I began by gluing in these short pieces for the motherboard I/O. When I would cut these down, I would use the miter saw and cut multiple pieces at once, which I would actually tape together. This is so 1, they would stay the same length away from the blade, and 2, to prevent tear out. For the top of the back panel, I glued a few short pieces down to where the I/O is, then once past the I/O, I attached longer strips that went down to the top of the GPU. For the very bottom where the power supply was going to rest, I bridged the gap with these small 3/4 inch squares. This frame was looking good, but I realized I needed to increase the number of layers on it by a fair amount, so I began to glue together 3 strips of wood at a time, making U's. I made 5 of these, then once they were dried, I took them all and glued them into one stack. I glued more spacers at the power supply end, then glued this entire extension piece onto the original frame. I then just kept adding strips, making sure to reference PC parts with each additional strip to make sure everything would fit and there wouldn't be any weird gaps. With all the strips up to the GPU, I set in the power supply and began figuring out where the next strips would sit. I also had this big gap between the GPU and the power supply, which I marked the length of and then cut a ton of strips to fill that gap. I glued these together a few at a time, continuing until I had a tall pillar to bridge the gap. I glued this to a few other strips for the back panel, then set the piece into place using the power supply to figure out where it should sit. I glued this with a bit of an overhang, which I knew I could cut out later. With most of the main chamber frame done, I took a larger sheet of plywood which I marked and cut down to a 15 by 3/4 inch square. This would act as the motherboard tray. Before I attached this to the frame, I needed to add a few pieces to the back that would allow other panels to attach to it. I took a scrap 2x4 and made a bunch of square dowels around 3/8 inch in size and then cut them to length on the miter saw. I used a scrap strip of plywood as a spacer and glued 4 dowels a 1/4 inch from the edge, which is where the panels would butt up against and glue to. With that done, I could glue the back panel to the frame, making sure to keep the frame square to the panel. With this attached, I used a few more strips to bring the frame to its final height and used smaller strips at the end to create a flat surface on top of the square. Like I said before, there was some overhang which I just cut off with a handsaw. Next, I cut down 6 strips of plywood that were 2 inches wide. I only needed 4, but I cut extra to make sure I had a few options if 1 or 2 turned out bad. I took the 4 I wanted and used a combination of a miter saw and file to create 45-degree angles in the ends of each side where they would butt up to one another. I used more of the wood dowels I cut down earlier and attached one to each of the strips using a plywood spacer. I was ready to install these, but I wanted to attach the motherboard and cut some holes in the panel before they were attached, which would make things a bit easier. I set the motherboard into place and and used the center punch to mark standoff locations. I took my drill and drilled holes in each of these marks, then installed standoffs in all of them. I haven't used any glue or epoxy for these yet because they seem to hold fine by themselves in the wood. With the motherboard placement decided, I marked out hole locations for all the various cables associated with the build. I decided to add the front panel holes slightly behind the motherboard to hide them. For these holes, I drilled out sections, then used a chisel to remove extra material and sandpaper to clean things up a bit. These holes aren't perfect and I will fix them up later, but for now they work fine. One other thing before attaching the 4 panels was to attach the front I/O to the top one. I used this audio and USB combo expansion drive along with a power button for the front I/O. For the front I/O, I had to cut this mount down a fair amount so that it would fit in the case. It took a few different cuts, but once it was how I wanted it, I clamped the modified mount to the top panel and traced holes. I drilled individual holes for the audio ports and was going to do the same for the USB ports, but just ended up cutting out a long strip for the USBs, which again doesn't look perfect, but I will fix this in the future. For the power button, I just cut a large hole which allows the button to slip into, and a nut at the button tightens it into place. With this done, I could glue all these panels together against the dowels on the back panel. While this was drying, I used the table saw to cut down a piece that would act as a back panel. This panel rests on the dowels I glued in earlier. I haven't found a good way of mounting this yet. I think I'll use magnets, but if you have a better idea, let me know in the comment section below. Next, I just glued the I/O into place, clamped it down, and let it dry. For the side panel, the closest thing I had on hand was the glass panel from the Thermaltake H18. It almost fits perfect, but there's not enough room to add screws, so I had to jerry rig it to the case with a few zip ties. I may end up just using acrylic for the side panel, but I would much prefer using a glass panel. With this being said, getting a custom tempered glass side panel would get very expensive. For the feet, I just glued alternating small and tall pieces of wood together. When dried, these just slot into the bottom wherever I want. This means if I want to upgrade them, changing from old to new feet takes all of 30 seconds. With the feet figured out, it meant the case was at a point where I was ready to build a system in it to test how everything fit and to test temps and stuff like that. I haven't figured out fan mounts yet, but I do have some ideas and even think I know how I can put a top mounted radiator in. With this being said, performance was decent with no fans, which you'll see later in the video. With the case explanation portion done, let's talk about the parts that I put in it. This isn't the final build for this case. I actually think this will house my personal rig in the future when it's fully done, but for now I built a pretty good gaming system inside of it and I'm going to share the specs with you now. For the CPU, I went with the Ryzen 3 3300X. This is pretty much the best value for the money gaming CPU, that is if you can get it. I was able to snag this one for the $120 MSRP, but it did take a lot of waiting for a back order to come in. This CPU has 4 cores and 8 threads. It's based on AMD's Zen 2 architecture and is unlocked, meaning you can overclock it. It comes with a stock AMD Wraith cooler, which I did use for this build. This cooler is pretty basic, but it gets the job done even with a mild overclock. For this motherboard, I went with my favorite AM4 motherboard, which is the ASRock B450M Pro 4. This board is a great value for the money, offering 2 M.2 slots, multiple PCIe slots, 4 DIMM slots, and a decent VRM setup. This is a perfect pairing with the 3300X, and the nice thing is that all of the current B450M Pro 4s being shipped have the BIOS necessary to run Ryzen 3000 CPUs. For RAM, I went with 16GB of Corsair Vengeance Pro RGB RAM at 3600 MHz. 3600 MHz is perfect for a Ryzen system and means I'll get the most performance possible out of the 3300X. These Vengeance Pro DIMMs look really nice in my opinion, and the RGB is some of the best I've seen on RAM sticks. 16GB is plenty for gaming in 2020, and only using 2 sticks means upgrading in the future is as easy as popping in 2 more. For storage, I went with a single 500GB SATA SSD. This is the MX500, which is a pretty well regarded SATA drive that works great as a boot drive because it does have DRAM. 500GB is plenty for the OS, applications, and a number of different games. Also, adding more storage is a simple upgrade, so starting with an SSD like this is a no-brainer. For the graphics card, I went with the NVIDIA RTX 2060. This is the Asus Strix model, which is one of the best versions of the 2060. Not only is performance on this card great, but it also looks awesome in my opinion. Also, with this being an RTX card, it has the ability to run real-time ray tracing and has other features like NVIDIA's NVENC encoder. For the power supply, I went with a 650 watt 80+ gold unit from EVGA. This is the EVGA 650G+. This is a high quality unit that that is fully modular and is very reliable. Normally this is the part where I would talk about the case, but I've already obviously talked about the case in length. Building in this case was pretty easy, and the large cable management chamber made things extra easy. I just let everything hang loose in the back, but will eventually add adhesive tie-down points in the back chamber, and overall I'm happy with how this build turned out. Like I said before, this case isn't 100% done, and I'm looking for your feedback on how I should finish it. One thing I really want to hear your feedback on is what kind of finish I should put on it, whether it's a stain or an oil or polyurethane or whatever you think. Let me know your suggestions in the comments below. I did do a few benchmarks on this system, and you can look at FPS numbers and thermals in the top left during these benchmarks, so without further ado, check out how this system performs. So as you can see, the combo of this 3300X and 2060 works great and stays relatively cool even without fans. With this said, the final hardware combo going in here will generate a fair bit more heat, which will require some fan and radiator mounts. All in all, I'm very happy with how this case and system turned out, and hope you are too. This project was a lot of work, but I'm hopeful the response to this video will make it well worth it. Thanks again to Surfshark VPN for sponsoring this video, and make sure to click the link in the description and use the code TechByMatt for 85% off plus 3 free months. So yeah guys, I think this wraps this video up. I hope you guys enjoyed it. If you did, make sure to give this video a thumbs up and consider subscribing. And as always, this is Matt from Tech by Matt, signing out.